Om Shri Sai Ram. In this session, we are going to see the second part of triangles. In our previous session, we saw about congruent, congruence, perpendicular bisector, bisector and SAS. That means side angle side congruencies and what are all the next congruencies are there. And also we solved some solvables on that basis. And also we have one assignment also. I think all of you have tried it, I think. If you have finished it, let us see whatever the steps I am doing and whatever the steps you have did, similar or not. So let us move on to our today's session. Today's topic, assignment. First we will see our assignment, then we will see theorems on properties of triangles. In that, what we are going to see is angle opposite to equal sides of an isosceles triangle are equal. Just see these words, we will explain it in the next. The sides opposite to equal angles of a triangle are equal. These both two theorems we are going to prove today and some solvables on the basis of these theorems. Let us move on to this session. So first assignment. So already I told how to do, but let us do it again. In right triangle ABC, right angled at C, M is the midpoint of the hypotenuse AB. C is joined to M and produced to the point D such that DM is equal to CM and the point D is joined to the point B. Now what and all we have to show? Here triangle AMC congruent to triangle BMD. Okay, that was the first one. Next, angle DBC. Angle DBC is a right angle. Listen, already they have given that C is a right angle. That means here already we have it is a 90 degree. C is a 90 degree. Now we have to prove B is also 90 degree. Okay. Next, triangle DBC congruent to triangle ACB. Next one, on the basis of this, next we are going to see CM is equal to half of AB. Now let us see first proof. What is the first one we have to prove? Triangle AMC is congruent to triangle BMD. So in this already it is given in the question that M is the midpoint of AB. What is meant by the midpoint of AB? That means it is breaking the whole length in equal half. That means AM is equal to BM. Why? Because M is midpoint of AB. This is already given in the question. Next, one more thing they have given that CM is extended to D in such a way that CM is equal to DM. So CM is equal to DM is also given in the question. Okay. So next thing, I want three things to tell so that both the triangles are congruent. I need three things. I need one more help. So who it will be? I need a side or I need an angle. I don't know about this side because in the given they didn't give anything about the side. So let me think about the angles. Which angle it will help? Here B, C, D, A, there is no connection between them. So who having the connection? M. Why? Because M is the intersecting point. We know in the previous class we saw that X, if we see what is there, we have an vertically opposite angles. We have vertically opposite angles. Okay, that means these two angles are equal. That is what we are going to use here. Angle AMC is equal to angle BMD. Why? It is a vertically opposite angle. Okay, so I have side, angle, side. So on the basis of SAS congruency, I can tell that triangle AMC is congruent to triangle BMD. I think you understand the first proof. Shall we move on to the next one? So next one, what we want? Angle DBC is a right angle. So in the next proof, what I have to prove? Angle DBC is equal to right angle, that means 90 degree. As per the proof, that means as per the help of the first one, I can tell that these two angles are equal. Now you have to see the Z here. Can you see? If there is a Z, there means alternate angles are there. If there is an alternate angle, means there will be a person who is at parallel lines. Is it right? Why? Alternate angles will come only in the parallel lines. So, DB is parallel to AC, since angle BDM is equal to angle ACM. By alternate angle theory, we can tell that BD is parallel to AC. Okay, so I have reached a point where I am telling that DB is parallel to AC. And next, one more thing. As per the parallel lines theory, angle ACB plus angle DBC should be equal to 180. I know that ACB is 90, DBC is equal to 180, then the angle DBC should be equal to 180 minus 90, which is equal to 90. Okay, so we proved the second answer. So let's see what is the third is. Triangle DBC congruent to triangle ACB. Triangle DBC congruent to triangle ACB. Here, from the first, I have told that BD is equal to AC. Okay, now from the second, I have proved that this B angle is 90 and C angle is 90. And I have BC on both the sides. That means BC is a common. So I have side angle side congruency. So my third one is proved. Okay, I think I don't have to write that third one. Let us see the last one. Here, CM equal to half of AB. Here you need to know something here. As per this third proof, whenever we are doing congruent, all the time our helper CPCT will come and stand near us. We are using it, we are not using it, he will come and stand. So, DC should be equal to AB. Next, half of DC should be equal to half of AB. Just I am multiplying with the half on both sides. That's all. I am not doing anything more than that. So now, DC half is DM. Is it right? Because M is a midpoint of both. DM is equal to DC. Here they have given already. DM is equal to DC. DC is the combination of DM and CM. So I can write DM plus CM is equal to half AB. Next, DM is also equal to CM. Now, who I want? CM here. Instead of DM, write as CM. So, it will be, I am writing here, half CM plus CM is equal to half AB. Now, CM plus CM becomes 2CM. So, it becomes 2. Half into 2CM is equal to half AB. That means So 2 cancels. So CM is equal to half AM. That's all. We finish our assignment. I told you this sum is little bit tricky, but this is a very important sum. If you are clarified with this whole exercise, you are ready. So shall we move on to the next? These are all the answers. You can check it. Now let us move on to the today's session. Some properties of triangle. Triangle. That means which triangle or what triangles we are going to see. In this time we are going to see about isosceles triangle particularly. Previous session I told you that isosceles triangle means two sides equal and one side not equal. So on the basis of the two sides we are going to bring the angles also. That is what here we are going to see. Angle opposite to equal sides of an isosceles triangle are equal. Angles opposite to the equal sides are equal. This is a very easy theorem to prove. Okay, so already they have used a word isosceles triangle. That means what they have given. So the given is AB is equal to AC. For my use, what I'm going to do, I'm going to drop a line. That means I'm going to break the angle A in such a way that will help me. I'm going to drop a line bisector for the angle A. Okay, so I have divided the triangle into, what are all the two triangles? A, B, D and triangle ACD. Okay, so in this already I have AB is equal to AC. So in this already I have AB is equal to AC. As per my construction, what I have, angle BAD is equal to triangle CAD. That means these two are same. Next, here AD common. AD is common. So AD is equal to AD. So now I have three members to support me to tell these two triangles are congruent. So by side angle side congruency, I am proving that triangle ABD is congruent to triangle ACD. So by proving congruent, what I am going to tell, that is what the thing is. If these two are congruent, already my helper will come and stand behind me. Who is my helper? CPCT. Yes, he will tell that your angle B is equal to angle C. How? Corresponding parts of congruent triangles. So he will help me to tell that, yes, since my two triangles are congruent, I can tell that angle B is equal to angle C. That is what I have to prove. Correct? Angles B is equal to angle C. That is what I have to prove, right? So what we did, let us see. Given isosceles triangle ABC, and since it is an isosceles triangle, we have a sides AB is equal to AC. Next, to prove, what I have to prove? B, angle B is equal to angle C. Next, for my convenience, I am constructing, draw a bisector of angle A intersecting BC at D. My proof, triangle BAD, triangle CAD. In that AB is equal to AC and angle BAD is equal to CAD by my construction, and AD is common. On the basis of angle side, I am proving that two triangles are congruent. My helper CPCT will give that angle B is equal to angle C. Hence, we proved the theorem. I think you understood this theorem. Please don't memorize the theorem. Understand the theorem perfectly with the diagrams so that you will never forget ever. Okay? So let us see the next one. This is also very easy one. Just ulta of that. So here the side opposite to equal angles of a triangle are equal. The side opposite to equal angles are triangle. You have to be clear that in the previous theorem they have used the word isosceles, but in this they did use the word isosceles. Why? Because that is what we are going to prove. We are going to prove the sides are equal. That is why they didn't use the word isosceles. So while writing the theorem, be careful. When writing the first theorem, you can write isosceles triangle, but here you are not supposed to use as isosceles triangle, just write as triangle. They have given here angle B is equal to angle C. Angle B is equal to angle C. Here what I have to prove? To prove AB is equal to AC. So as if in the previous thing, I have one, I need two more. So what I have to do? Same construction. What I'm going to do? To construct a line starting from the vertex A to the line BC, touching the point D in such a way that it divides the angle in equal. That means I'm going to draw a bisector line. That's all. Draw a bisector line for angle A. So draw a bisector line AD. Draw bisector line AD, bisector to angle A. So for in that what I get? I will get 10 equal angles. Okay ba? So now I have two triangles. If I have two triangles, I can easily prove that two triangles are congruent. If I prove that two triangles are congruent, my helper CPCT will come and tell that both the sides are equal. Let us do that. In triangle ABD and triangle ACD, what I have already, I have angle B is equal to angle C, and my construction angle BAD is equal to angle CAD, and already AD is there common standing there, so let us use that also. So AD is common. Angle side congruency, I can tell that these two triangles are congruent. So next, who should come? Yes, CPCT. Because of that CPCT, what I have told one side. Is it right? Two more sides are there. Who are they? BD, DC and AB, AC. So what I need, I don't want BD and DC. So I want only AB is equal to AC by CPCT. That's all. I think you've understood. Let us see. Given triangle ABC, angle B is equal to angle C, we have to prove AB is equal to AC. So I am going to do a construction that angle, draw a bisector in the angle intersecting. My proof, what I am going to prove? What is given, what I constructed, and what I have already. So next, because of that angle side, yes congruency, I am proving that two triangles are congruent. Now my helper will come and he will tell that both the sides are equal. Thus I proved my theorem. So I think you understood this. Let us do the sums. Sums will be easy only. When it will be easy? If you start with the diagram, then it will be easy. See, in an isosceles triangle, see the word isosceles triangle, they will not give that the sides are equal, this side is equal to this side. They will not give. They will never give. Isosceles means you have to think that yes, these two sides are equal, like that. You have to understand that. Your brain should tell looking at the isosceles word itself. Next, with AB is equal to AC and the bisectors of angle B and angle C intersect each other at O, join A to O, show that OB is equal to, this is too much clumsy. Let us draw that. So what they are telling? There is an isosceles triangle where AB is equal to AC and angle B and angle C are having a bisector. That means there is a line drawn through the angle and it is intersecting in a place called O, and if I join AO there, then I have to tell that OA is equal to OC, and I have to tell that OA is the line, is not a simple line, it is a bisector line. Okay, so let us start the proof. If you are starting a solution, you have to start with given. Never start with directly, I know the answer, so I will write first. No. First start with given. Next to prove. Then only we have to go to the proof. OB is a bisector of angle B. So ABO OBC is equal to half of angle B. The same thing for the angle C also. So I don't want to repeat it. Since AB and AC is given equal to AC, AB is equal to AC given, and ACB is equal to ABC. So we get that half of ACB is same thing. So I get OCB is equal to OBC. Hence we proved that OB is equal to OC. Now we have to prove the next one. Who is the next one? I have to prove that OA is a bisector line. What is meant by bisector line? These both are equal angles. Let us take it as Y and Y. In triangle ABO and ACO, already they have given AB is equal to AC. AB is equal to AC is already given in the question, and OB is equal to OC. Now I have proved. So the last one, angle OAB is equal to OAC. So which implies that OA is bisector of angle A. So now we finish this. Let us move on to the next one. ABC is a triangle in which altitudes BE and CE of two sides AC and AB are equal. So if we read this question first time, everyone will think that they have given side AC and AB are equal. Is it right? Think again. ABC is a triangle in which altitudes BE and CF to sides AC and AB are equal. Then show that triangle ABE is congruent to ACF and AB is equal to AC. In the question they have given AC and AB are equal. Then why they are asking AB is equal to AC? You have to prove. That is what the wrong. That means misunderstanding we are doing. Read the question perfectly. ABC is a triangle in which altitudes BE and CF to the sides, they are not equal. These two are equal. The persons who are reaching them are equal. They are not equal. The persons who are reaching them as an altitude, they are equal. So we have to be very clear when reading the problems. Let us see the diagram. ABC is a triangle. So ABC is a triangle, and they have given BE and CF altitudes. So altitude, what is the meaning of the altitude? Altitude means starting from the opposite vertex, reaching the opposite side in how? 90 degrees. It will make 90 degree. Correct? So altitude means, as per the definition, the line should make an angle of 90 degree. As per the straight line, you have already learned that if there is a straight line, one side is 90, then other side will also 90. The same thing applied here also. Okay. Now, so what do we have to prove? Triangle ABE congruent to triangle ACF. ABE congruent to ACF. So, how many triangles I have? So, what and all things I have to take? How to show this? No problem. Start from here only. Start from here. In triangle ABE and triangle ACF. Okay, ma? Now think what are all the things they have given. BECF equal. Correct? BECF equal. BE is equal to CF. Okay, va? And with the word altitude, they have given a angle also. That means BEA is equal to CFA, right? BEA is equal to angle CFA, which is equal to 90 degrees. In both the triangle, I have a common person angle A. Correct? So, by who I am telling it is a congruent both the triangles? Side, angle, angle. On the basis of angle, angle, side, I am telling that both these triangles are congruent. Okay, what I am going to tell? On the basis of angle, angle, side congruency, I am telling triangle ABE is congruent to triangle ACF. By CPCT, I can prove the next proof also. Let us see the proof given. They have used the word altitude, so I have used the symbol perpendicular because perpendicular will lead to the angle 90 degrees. So BE is equal to CF, that is given. Show that the triangle AB is congruent to ACF. AB is equal to AC. The sides are equal means I can tell them as a isosceles triangle. So proof, what is the proof? ABE and ACE, that is I took it from the question only, not from my own. Since altitude is given, angle is 90 and common angle A, which is common, and BE is equal to CF, which is given. So by angle, angle, side congruency, I am proving that triangle AB is congruent to triangle ACF. Through my CPCT, I am proving that AB is equal to AC. So this is a very important one. Please think again. Now, next, the last one of this session. Triangle ABC is the isosceles triangle in which AB is equal to AC, sides BA is produced to D such that AD is equal to AB. Too much things, is it right? So we will go one by one. Triangle ABC is an isosceles triangle in which AB is equal to AC. Side BA is produced to D such that AD is equal to AB. That means indirectly they are telling AD is equal to AC. Why? AB is equal to AC. AB is equal to AC and AB is equal to AD. So AD is equal to AC. Is it right? So next what they are telling? Show that BCD. That means I have to join D and C. Here they didn't told join C and D like that. They directly gave that angle BCD is 90 degree. That is what we have to prove here. Right? Let us go to this angle. Here, if I take this as 1, angle 1, this should be angle 1. Right? If I take this as 2, this should be 2. Right? On the basis of isosceles triangle. So here we have two isosceles triangle such that angle B and angle C are equal on the basis of AB is equal to AC. And so we are not supposed to tell that angle B and angle C because C is not a whole angle. We are not supposed to tell like that. We have to tell as ABC is equal to ACB on the basis of AB and AC, and ACD is equal to ADC on the basis of AC is equal to AD. So our proof starts here. Triangle ABC, AB is equal to AC. So angle ACB is equal to ACB is equal to ABC is the first. Next, in triangle ACD, AB is equal to AD. AB is equal to AD. So AD is equal to AC. That is already we know that. So on the basis of that, our own 1 and 2, 1 plus 2, the same thing. See. So we took this as 1. We took this as 2. 1, 2. Okay. So now BCD becomes angle 1 plus angle 2. Okay. Now what they have asked, we have to prove that BCD angle is 90 degree. That means I have to concentrate on one triangle. I want a triangle BCD. Correct? Already in my previous 8th standard and 7th standard, I learned that sum of the angles of a triangle is 180. Is it right? So let us take all the angles DBC plus BCD plus CDB, which is equal to 180. That means 1, 2, 3. All the three angles, sum of the three angles is equal to 180. Okay, that is what we learnt already. So here BCD I have a, so keep that BCD as it is. DBC, CDB. I have heard somewhere. Where? Oh my god, where? I don't understand. So what I have to write here is just little bit changes in that. How I am going to change is next. Here I am changing that as ABC. Why? Here it is DBC. How can you change this as ABC? The angle never changes on the basis of the length of the arm. The angle never changes on the basis of the length of the arm. So now DBC is equal to ABC. Now you understood why I have wrote DBC is equal to ABC. Why? Because D is the extended point of A. Correct? That is why we have wrote as DBC as ABC. Now BDC. Here B is the extended point from A, right? B is the extended point from A. That is why I have written as BDC as ADC. Okay, so BCD same as it is. Now see these two. Have you ever seen this before? Yes, I have seen here. Just for this, write as BCD. For these two, change it as BCD. BCD is equal to 180. X plus x is equal to 180. Then 2x is equal to 180. So the x is 90. So we proved the sum. And if we have done the sum, the last one is our assignment. This is the very easiest sum. Here you are seeing two triangles. Just you have to make one more triangle just by dropping a line here. Just dropping a line here. If you create other two triangles, means easily you can solve this. That is a hint I have given. You have to drop a line. That means you have to join AD. That's all. AD is common. AB is equal to AC. BD is equal to DC. Since by side congruency you can prove that triangles are congruent, so the angles also congruent. With the help of CPCT you can do it easily. So this how we finish our this session. Thank you. Sai Ram.